Good morning, good afternoon, good evening. Thanks everyone for joining at various times all around the world. We're really excited to bring to you the first webinar in this series about the Better tool. Today we'll focus on collecting and preparing data to use the Better tool to improve building energy performance. And we are delighted to have two expert speakers on the line from Lawrence Berkeley National Lab, Carolyn and Han. So I'll give a quick introduction from the Building Efficiency Accelerator. My name is Debbie Weyl. I'm the manager of the Buildings Initiative at WRI, and we are the secretariat for the Building Efficiency Accelerator. So we'll tell you a little bit about that platform, and then we'll just jump into the content for today. So the bulk of the time that we have will be hearing from Carolyn and Han about how to collect and prepare data for the Better tool. And we also importantly want to leave some time for questions and discussion at the end. So we hope that you will stay with us to ask those critical questions of us. You can also ask questions through the GoToWebinar platform. So if you look over on your GoToWebinar interface, you should be able to ask questions in writing there that we can also respond to at the end. So I think many of you are familiar with the Building Efficiency Accelerator. We are a platform that currently has 55 partner cities and states in 25 countries all around the world. We have been in operation since 2015 as part of the Sustainable Energy for All platform. And we also now have 3 soon to be growing national, subnational engagements on, we're focused on city action and subnational action, but we also know that there are barriers to city action that are best addressed through collaboration with the national government. So increasingly also looking at that approach. And as you can see, we have a global presence, and we're excited to talk a bit today about how the Better tool has already been used and piloted in a lot of these different regions. To support those cities and states all around the world, we have over 50 global partners as well, including nonprofit NGOs, associations, multilateral organizations, and private sector companies. The Building Efficiency Accelerator is a public-private collaboration, and really critically, we're looking to use policy and programs to transform the markets for energy efficient and high-performing buildings. The BEA provides a number of things to the cities and states that join. We help the decision makers to prioritize and track which actions they would like to pursue. We provide tools, expertise, and solutions to help them better and more quickly achieve those goals. And one of those, of course, is what we'll be talking about today. We aim to connect projects in need to financing and funding opportunities. And we also serve as an excellent avenue for international recognition and collaboration. The work that is happening in cities all around the world is incredibly impressive, and it's often really hard to get that awareness sort of out of the city and into the onto the global stage. And the Building Efficiency Accelerator provides an excellent platform to do that. For technical assistance, we provide 4 main levels of technical assistance. We have deep engagement in a number of cities and countries around the world, currently in approximately 10 cities and 3 countries. And we also provide direct technical assistance in a more targeted way to help cities to overcome a specific barrier or obstacle. Through our platform, we have a peer learning network connecting cities to each other to help learn from the experiences that others have had. And then the most general, we have PLAYBOOKS, which is a new product that we're really excited to share as well, focusing on these 3 key topics: building energy codes, building retrofits, and building efficiency targets. These topics were chosen based on the interest of cities and what we've been seeing cities prioritize. And so the playbooks provide step-by-step guidance to help cities understand where they can start in addressing these key topics and how they can walk all the way through the process from committing to taking action all the way through to implementation and improvement. The Better tool is really associated with the Building Efficiency Targets playbook, also written but with the expertise from Lawrence Berkeley National Lab. And again, it provides the step-by-step guidance for local governments on how to develop and implement voluntary existing building energy efficiency targets. So how do you improve the energy performance of your existing buildings? It has several case studies, including a detailed case study from the Changning district in Shanghai on how to successfully implement those steps. If you don't already have access to that playbook, please let us know. There also will soon be, in the next few months, there will be a learning guide that is a higher level overview of that playbook that you'll be able to walk through online through an online platform. To get to the Better tool, the reason we're all here today, very briefly, the Better tool is an open source, very easy to use tool that targets efficiency improvements by turning monthly energy consumption data into recommendations for energy efficiency improvements. The BEA has been really pleased to be able to support providing feedback on the value of this in the local context, as well as being able to test and deploy this in a number of places. You can see that there has been pilot use of this in Colombia, Costa Rica, Eskişehir, Turkey, Nagpur, India, Sonora, and South Africa. And so we have been really delighted to be able to help test, pilot, and deploy this really critical tool, and especially now in this time when we know that in-person interaction is quite limited, that in this time of COVID, of this global pandemic, that we're looking for ways that we can support local economies as well as continue to move the work forward on building performance, and the Better tool being able to use this remote tool with easy to access data to help us understand what are the improvements that we want to prioritize for once we all can be back and active in our communities. This is going to be a really key tool that we can use in the meantime to help tee those up. So with that, I will pass this on to Carolyn to tell us more about the tool and about how to collect the data.
Thank you so much, Debbie. It's a pleasure to be here today. Thank you so much for that wonderful introduction. I'm just going to get my slides set here. Okay. So good morning, everyone. My name is Carolyn Szum. I'm with Lawrence Berkeley National Lab, and I'm going to talk to you today about preparing data and using the Better tool to improve building energy performance. By the end of today's webinar, our team wants you to have a solid understanding of what Better is and how it can help you to improve the energy performance buildings within your city or your portfolio. Also, how to collect, where to collect data from, and how to prepare that data to use Better. And then how to input data into Better to generate an analysis that can be used to set energy performance baselines, energy performance improvement targets, and to develop a quick win strategy, which would first focus on simple, no-cost, low-cost operational energy efficiency interventions that could be implemented across a portfolio to capture quick energy and cost savings before you go to implementing deeper energy savings measures. We'll touch on these in terms of high-level concepts. There's a future webinar that'll go into a lot more detail on those energy efficiency interventions, and I'll talk about that near the end of today's presentation. So our agenda today, we're going to provide a high-level introduction to Better, talk about the data requirements and different upload options, the overall analytical methodology of Better, and then my colleague Han is going to give a live demonstration of Better. He'll show you how to input data, how to run the tool, and the types of analytical outputs that are available. And then we'll talk at a conceptual level about utilizing those results. So I'd like to first acknowledge Johnson Controls, our cooperative research and development partner for development of Better. Without Johnson Controls, this open source public access tool would not be available. And also ICF International, who is a critical partner in developing the alpha and beta versions of the tool. So a little bit of context. You know, as Debbie mentioned early on, buildings are a critical component of achieving overall carbon dioxide mitigation goals. Currently, buildings account for about 1/3 of global energy demand and 1/4 of global greenhouse gas emissions. Research shows that global building energy demand could be reduced by 1/3 by 2050 if known energy efficiency best practices are implemented on a large scale across regions. And of course, we see this Better tool, a remote analytical tool, as a critical component of the suite of resources that could be brought to bear to identify and implement energy efficiency practices at scale all around the world. So what is Better and what is it supposed to do? Better is intended to provide building owners and managers with an open source, very easy to use tool to target efficiency opportunities by turning readily available monthly energy consumption data into specific, measurable energy efficiency interventions, both operational and equipment or technological, at the building or portfolio level. It's important to recognize that the Better tool doesn't replace an investment grade audit, but it can be used as a pre-audit to help streamline and validate an audit. In other words, to screen buildings ahead of time to identify those that offer the highest energy and cost savings opportunities, and for which you'd want to potentially undertake an audit. And when you undertake that audit, to be able to use Better's outputs to ensure that you haven't missed any key energy efficiency opportunities. Second of all, Better is not intended to be a rating tool. So you may be familiar with the U.S. Environmental Protection Agency's Energy Star Portfolio Manager tool, which does rate building energy performance on a scale of 1 to 100, where 100 is top performance. Better doesn't do that. We're focused on finding buildings and finding interventions to reduce energy costs, usage, and emissions. Lastly, our tool complements a whole suite of U.S. Department of Energy tools, the Energy Star Portfolio Manager that I just mentioned, Asset Score, Building Sync, Standard Energy Efficiency Data Platform. So we kind of fit within this ecosystem and support other publicly available building energy analysis tools. So in terms of where we are in the Better development and launch process, last year around this time, we released an alpha version of our tool publicly. That tool was copyrighted, web-based. You can see the URL in the upper left there. Open source, of course, and our Python code is available on GitHub for software developers and engineers who may want to take that code, integrate it with their existing software platforms, repurpose it, redevelop it, etc. They would just need to comply with our copyright and licensing terms. As mentioned earlier, Better runs on readily available monthly energy usage data and a few other data points, building size, location, and type. I'll get into a lot more detail on that shortly. I should say, here's a little snapshot of the data that our tool requires, and we'll go into a lot more detail shortly. We automatically regress monthly electricity and fossil fuel usage against ambient temperatures, and you can see in the upper right there an example of an electricity change point model. This is one of the tool analytical outputs. We also benchmark 5 regression model coefficients. You can see there electricity consumption benchmarking. We look at heating and cooling sensitivity, base load, and heating and cooling change points. And Han will talk about that as we get into the live demo. We also quantify energy and cost savings potential at the building and portfolio level. Really important component for evaluating energy efficiency opportunities remotely and at scale. And of course, recommending measurable action-oriented energy efficiency interventions, operational and equipment. The tool will be able to tell you not only at a building level what the energy efficiency opportunities are, but also at a portfolio level, what are your top 5 energy efficiency opportunities that you could implement at scale. Just recently, in the past several weeks, we launched our beta version of Better. It's now available on our website. The beta version has built-in reference benchmark statistics for US offices and K-12 schools, which means that any building anywhere in the world could ostensibly take data for a single building and measure performance, benchmark performance against a larger set of US offices or US K-12 schools. We're still testing and refining those underlying benchmark statistics, but they are available for pilot use with the beta version of Better. We're also in the process of developing a RESTful application programming interface that would allow users to exchange data with Better using a JSON schema and to receive Better metrics in that same format that they could then integrate into their software applications. We have an Energy Star Portfolio Manager data export function, which allows users of Energy Star Portfolio Manager also to generate Excel-based reports that can be automatically read and analyzed by Better. And we'll talk about that a little bit later. We've really reduced the runtime of Better to incorporate a paralleled inverse modeling process for large portfolios. And we've also incorporated estimated greenhouse gas emission intensity levels and reduction potential into the tool. So currently, who's using our beta version and what are they using it for? You can see here a snapshot of different stakeholders in public and private sector that have taken advantage of the Better tool. So we're working with several energy service providers, both large Fortune Global 500 ESCOs like Johnson Controls and Schneider, and some of smaller ESCOs, Energy Systems Group, for example, Energy Resources Integration. We've also brought on board some real estate investment companies, CB Richard Ellis, which is the world's largest commercial real estate company, and also Blackstone, which manages the world's largest real estate portfolio in terms of, I think they've got more than $300 billion of real estate assets under management. Number of cities and states, you can see school districts. We're really excited for the work we're doing with the Prince William County Public School District in Virginia. They've taken an ambitious lead to assess opportunities for energy efficiency improvement across 63 elementary schools in their portfolio, and also partnerships with ASHRAE and the Judicial Council of California. So as I mentioned, these different organizations are doing different things. CBRE, Blackstone, and some of our energy service providers are working together to select buildings with high potential for increasing net operating income and asset value through operational improvements. They're also looking to support compliance with benchmarking and transparency laws that exist in the United States. States and cities are looking for ways to use Better to offer additional analytics to benchmarking and transparency policy participants. Prince William County Public Schools is trying to identify no-cost, low-cost operations and maintenance measures, targeting buildings for audits as well. Judicial Council of California, we're so excited to be working with. They're using Better to give pre-audit highlights to some of the worst performing buildings in their courthouse portfolio and to select buildings for retro-commissioning site audits. And then of course, ASHRAE beginning to have conversations about incorporating better into ASHRAE courses, procedures for commercial building energy audits and effective energy management in new and existing buildings. We've gotten some great feedback from our pilot users of Better. I love what I see. Really an impressive tool. Better goes a lot deeper than what we do with remote analytics, particularly with heating and cooling loads. Tool gives us great insight on potential energy savings opportunities prior to visiting a site for an energy audit based on that readily available monthly normalized energy and cost data. So we hope from today's webinar that we'll find more pilot users who can give us constructive feedback on the tool. As Debbie mentioned, through partnership with World Resources Building Efficiency Accelerator, we're also taking Better to the world, and we're seeing Better being used in about a dozen emerging markets. For the most case, the tool is being used to establish building and portfolio energy and greenhouse gas reduction targets, to benchmark buildings against US and international standards, to identify and quantify energy emission and cost savings potential, to select buildings for audits and retrofits, and also to identify quick, no-cost, low-cost operational opportunities to reduce energy usage and cost. So with that context, I'm going to talk about now, if you'd like to use Better, what data is required. And in partnership with Johnson Controls, it's our aim to keep the data inputs as minimal as possible, but yet still generate useful analytical outputs that can help to improve energy performance in buildings. So in terms of the data requirements, first and foremost, Better requires the following information about buildings. We need to know, what unit system are you going to be working in? Are you going to be working with imperial units, feet, kBTU, temperatures in Fahrenheit, or are you working in standard international units such as meters, kilowatt hours, and degrees Celsius? So you need to select one of those two options. For every building that you analyze using Better, we need an ID number, simply an integer number that you assign. So 001, 002, for example. We also need building name, which can be any unique name assigned by the user. We don't need to know the true name of the building. You can give us proxy names, Office 1, Office 2. Most important is location. So if a building is located in the US, our tool requires information such as city and state or postal code. If the building is located internationally, just the city and country is sufficient. We also require for each building that Better analyzes the gross floor area, excluding parking. And what we mean by gross floor area is the area of the building as measured between the principal exterior surfaces. It should include area for parking. It should be provided in square feet or square meters. Excuse me, it should exclude area for parking. And it should be provided in square feet or square meters. Also, we need to know the primary building space type. So is the vast majority of this building a hotel? Is it an office? Is it a hospital? And we're just looking for primary space. And lastly, currency. So do you want to see outputs in US dollars, Chinese renminbi? That information will allow us to understand how do we communicate financial savings to you in the Better analytical outputs. So that's the building data. In terms of energy information, we need 12 to 36 consecutive months of energy usage data for all fuels used in the building. So that means for each fuel, we need at least 12 consecutive months of consumption and cost data. We need the monthly billing start and monthly billing end date for each fuel. We require a specified format shown here on the slide. We also need to know the energy type. Are you talking about electric grid purchased energy, natural gas, district steam? the units that you're providing that data to us in. So is this kWh of electricity, therms of natural gas, and the monthly energy usage. So just a numerical consumption value associated with the fuel use and the monthly energy cost. If you don't have cost information, we have some workarounds. We've got some proxy cost information, but you'll get much more accurate financial results if you do provide us with the monthly energy cost as well. So we'll go into this later in the presentation as well. Han will actually show you how to input this data. So that'll be a refresher, but this just gives a snapshot. Here's the data that Better requires. So if you're a city official or a manager or owner of a large portfolio of buildings, you may not be tracking the energy performance of your buildings. So we put together sort of a snapshot of typical building and energy data sources, places you might look to get this data. So I'm going to run through this and quickly, and then we can talk about any challenges you faced collecting data and where we might be able to offer ideas for getting the data necessary to use this tool. But land and tax data is a potential source. So government entities should have information about properties in the city. They may not have information about the property owner, but they would have basic information about the property itself, maybe the building size, course location, things like that. You may also be able to get data on buildings from universities and research institutions, particularly for university campus buildings, public buildings. Those are great partners in the data collection effort. Private consultants oftentimes have data that they've collected. They may have restrictions on sharing the building and energy data, but there's certainly a potential source. Government data as well. So cities, provinces, states, national departments often carry building and energy data. You could discuss potential sources with city administrative officials, the sustainability and or environmental protection offices, the housing or community development offices, general services administration, public work offices, etc. All would potentially carry data on buildings within a city or a province. Real estate data, so data that has been collected with regard to the potential or the recent real estate transactions and which is available for sale. Again, real estate data, you'll get information about location, size, building type, maybe the current owner of the building. Other sources include energy data from building owners, facility managers, and ESCOs. So great sources for energy data, in my opinion. So monthly energy consumption values by energy type, along with location, size, etc. Many times ESCOs have information from utilities associated with the energy consumption and costs for a given building. If your building has an energy monitoring system and smart meters, of course, these would be great places to collect energy data, either at monthly intervals or 15-minute intervals, if available. Also utilities, certainly many of them have programs which allow building owners and managers to designate third parties access to energy data. So also a great place to get data. Maybe audits. Audit data will include building location, type, floor area, typical monthly or annual energy consumption values by type. You can also get a lot more detailed information on construction and equipment characteristics from an audit data package. Architectural or engineering drawings also can provide valuable information on a building. So this is a snapshot of different places to get energy data, to get building data. What primarily users of Better access in order to identify the energy data required for Better is simply their utility bill. So monthly utility bills will provide all the energy information you need for Better. And of course, when it comes to size, location, and type, some of these other resources that I mentioned can offer valuable insights. So with that, I want to talk about the different data upload options that Better offers. So we offer a few different ways to upload the required data into Better. So option one is our data upload Excel template. It's available on our Better website. It's downloaded with the click of a button. And users of Better simply fill out this multi-tab spreadsheet with the information I mentioned earlier, such as unit systems, building ID, building name, location, gross floor area, and primary building type and currency type, along with, on the second tab, monthly energy information, including building ID, billing start and end date, the energy type, energy unit, energy consumption value, energy cost value for at least 12 consecutive months for all fuels used in the building. More recent data is better, so the most recent 12 months would be ideal and give you the most recent picture of energy performance in the building, but you can stretch back further if that's the only data you have access to. A second way that users of Better can upload data into the tool is if a building is using, or a building operator is using the Energy Star Portfolio Manager tool. This is a free public access tool offered by the U.S. Environmental Protection Agency, and it's used by about 40% of U.S. commercial buildings and a large number of buildings, in fact, around the world, because of some of the international metrics that are offered within the tool. But if a building or a portfolio of buildings is part of the Portfolio Manager software platform, there's a feature that we've developed for Better that allows a user of Portfolio Manager to develop an Excel-based output report, which includes the information shown here on the slide, so some basic property information and meter entries, and to auto-generate that Excel report in Portfolio Manager and then upload it to Better. And our tool has stepwise guidance for users on how to generate that Excel report within Portfolio Manager. And I think Han can show you when we do the live demo where you can download those stepwise instructions. A third option that's under development, so it's really a bit of a future option, but it'll be an important component of Better, is the RESTful application programming interface, which would allow a user to exchange data with Better and receive our metrics that could be then rendered into their existing software tools and platforms. This offering, we're still in the process of testing, adding some security features and addressing some bugs. And it also requires coordination between a client software engineering team and our own software engineers at LB&L at this stage. But it is something we're working toward to allow for very large scale bulk data transfer and for certain clients to integrate our analytic outputs within their own software applications. So in terms of the different options, we sort of provide a snapshot here and talk about some of their advantages and limitations, and also some case examples. So really, first and foremost, we recommend, for the most part, folks that are part of this webinar to focus on using the Better Excel template. This is the most often used, frequently tested, highly secure way to transfer data into Better for analysis. We have comprehensive instructions, step-by-step guidance, and how to use this. Some of the limitations, lacks flexibility. You have to use our format, and if you have a large number of buildings that you want to analyze, you're either going to need to enter those buildings manually into our template or use some sort of script to enter that data into the Excel format. Prince William County School District recently transferred about 60 plus elementary schools to us in this format, which worked very well. Judicial Council of California also uses this approach when uploading data to Better independently. Although available, you know, not highly recommended, but available is the Energy Star Portfolio Manager template. Again, if you have data entered into Portfolio Manager, this could be a great option. You can automatically generate an Excel report that can be read by Better. We know that Portfolio Manager isn't often used outside the United States, so this may not be the best option for BEA partners. But if you have buildings in the US, this may be a great option. There are some fields that aren't available in the Portfolio Manager Excel output reports, like currency type and custom weather inputs. So we have to work around that. The City of Cambridge recently provided us with data for more than 35 space types and 500 buildings using this format. So certainly cities can take advantage of this type of bulk data transfer. And then, as I mentioned, our API is still under development, but some of the advantages that we see, it's avoiding spreadsheet hassles, it's very software scalable, and our analytics can be rendered in a customer or client's existing software platform. But again, we need further testing, bug fixes, and security. So that's kind of a snapshot of the data associated with using Better and some of the upload options. So I'm going to begin now with talking about Better's analytical methodology. What do we do with the data that I've just mentioned? How does this tool take advantage of that data to provide energy efficiency, cost and energy usage and cost savings potential, and recommend energy efficiency improvements? So here's a snapshot of the overall workflow. We're taking the building data I mentioned, the energy consumption data I mentioned, and combining it with weather data from the National Oceanic Atmospheric Administration, NOAA database. We're pre-processing that data, and I'll talk about what that means in a moment. And then we're using an inverse modeling function to essentially plot energy use intensity, typical energy use intensity per day in a given, typical energy use intensity during a given month. So what's your average energy use intensity per day in a building in January? And what's the outdoor weather in January? And so we're plotting energy use intensity levels against ambient temperature to understand weather independent and weather sensitive energy consumption in a building. We create inverse models. You can see a quick sort of view of a simplified inverse model, which tells us a little bit about how the building is using energy, and also the types of energy efficiency opportunities which would therefore exist. So we get metrics such as base load energy performance, which is the weather independent energy usage in a building. We get heating and cooling change points, and we get heating and cooling sensitive consumption, which has to do with how quickly does a building start to consume energy for heating or cooling as outdoor air temperatures rise or fall. And we'll talk about that in a little more detail later. We take those coefficients that I mentioned from the inverse model, and we benchmark them against a larger data set. Either underlying statistics that we've developed from the US national stock, or statistics that we develop based on a user's own portfolio. If they've got 30, 50, 70 buildings, Better will generate statistics particular to a specific portfolio, and we can benchmark any given building in your portfolio against those underlying statistics for your portfolio. And we'll give you a sense of, well, is your building's base load, cooling and heating sensitivity, cooling and heating change point, are you good, typical, and poor for this particular building? And how you rate on each of those metrics will give an indication of the types of energy efficiency measures that exist for your building, and also the energy and cost savings potential. And we summarize all of this in a couple of reports. So again, property information, I've already touched on this. Here's the type of building information Better requires. Monthly energy consumption, again, here's the type of energy usage and cost Better requires. The weather data, this is automatically downloaded from NOAA. We download it in a sub-hourly format, and we determine what weather data to pull and integrate into a building's analytical process based on the address information for the billing and the billing period start and end dates. So as I mentioned earlier, there are two ways that Better can provide benchmarks and analysis for any given building. We can benchmark your building against a built-in reference data set, whereby currently we have a built-in reference data set for US offices and US K through 12 schools, and we're working on several other built-in reference data sets, hospitals, hotels, potentially universities. Or you can, if you've got a large enough portfolio, again, 30, 50, 60, 70 buildings, you can benchmark any given building in that portfolio against your own reference data set. Better can auto-generate benchmark statistics customized for your specific portfolio. So once a user has brought data to the table, they've entered it into Better, they've selected the type of analysis they want to do, whether it's benchmarking against their own portfolio or benchmarking against our Better reference data set. The next step is data pre-processing, and this is happening on the back end, the analytical engine, where Better is going to read the building information that you provide, the address, the space type, the gross floor area, the monthly energy usage and cost data. It's going to search for the closest weather station, and it's going to take all the different fossil fuels that you might be using in a building and convert all of that fossil into one particular unit. So on the back end of Better, we use kilowatt hours. Simultaneously, we'll be downloading a sub-hourly weather file from NOAA, and then we'll normalize the energy consumption to show average kWh per day per square meter or per day per square foot by month for at least the last 12 months. And we'll align that with weather data for those particular periods. So as I mentioned, we get any of the following schematic plots, which show the relationship between outdoor air temperature and energy use intensity within the building. So Better can provide up to 4 model types, a 1P model, a 3P cooling model, a 3P heating model, or a 5P model. And you can see what those models look like in the second column of this chart. And from those models, we generate up to 5 coefficients for each model. Those coefficients include base load, cooling sensitivity, cooling change point, heating sensitivity, heating change point. And Better interprets those models in different ways to tell us again about the weather independent and weather sensitive consumption in a building. So if we take, for example, a model, the 1P model, where you can see the schematic plot is essentially a horizontal line. Regardless of changes in outdoor air temperature, the energy use intensity of the building stays relatively constant. So what we would infer from this is that the building is not sensitive to changes in outdoor air temperature, and we don't see increases in energy being used for heating or cooling. In the second example, a 3P cooling model, here we would see at a certain temperature, the cooling system of the building would start to operate. So that temperature we would call the change point, and then that slope, that steeper slope, that alpha 1, would indicate that as our outdoor air temperatures rise, we see higher consumption growth within the building for, again, in this case, cooling. The steeper the slope, the higher the energy consumption growth as outdoor air temperatures rise. A very steep slope might indicate that a building could benefit from some energy efficiency improvement measures related to a more efficient HVAC system, changes in building envelope, etc. So those are just a couple of examples. We offer, again, 4 schematic plots, 4 model types, and from these model types, we glean 5 model coefficients that we benchmark and analyze in order to determine a building's weather independent and weather sensitive energy consumption and the types of energy efficiency opportunities that exist. So once we generated those model inverse model coefficients, we would, as mentioned earlier, we would need to benchmark either against some built-in reference benchmark statistics or from benchmark statistics that Better develops for your own portfolio. So in this case, let's take the example of electric baseload, where Better provides us with information about the electricity baseload for any given building. And we compare that one individual building's electric baseload against a larger data set from which we've derived the median and standard deviation for electric baseload for that larger data set. And so we take this one individual building that we're looking at and we compare it to the benchmark statistics, the median and standard deviation for the entire database. And if we see that the performance of the electric baseload for that one individual building we're looking at is better than 1 standard deviation from the median, we would consider that to be good performance. If the coefficient for the electric baseload is worse than 1 standard deviation from the median, we would consider that poor. Anything else we would consider to be typical. So it's a very simple and straightforward benchmark analysis. In this particular example, the electric baseload is better than 1 standard deviation from the median, so we consider that good performance. We do this type of analysis within Better for all 5 of those coefficients of performance from the inverse models. And we do this for both the electricity consumption and for the fossil fuel consumption. And with fossil fuel consumption, we're combining all the different fossils used in a building with its natural gas plus diesel or whatever's being used in the building. And we provide an analysis: is the electricity baseload poor, typical, or good? Is the cooling sensitivity, electric and fossil, poor, typical, or good? So this is really a big piece of the analytical methodology. The next component is when a user works with Better, they also have the option to specify their own energy efficiency targets. Are they looking for very aggressive energy performance improvement? If so, Better would in the analytical engine set energy efficiency targets that are 1/2 standard deviation better than the data set median. If a user was looking for a more nominal performance improvement in buildings and across their portfolio, they would set a target as nominal. And what that means is that the target within the analytical engine would be equivalent to the median for the data set. And then thirdly, there's an opportunity at this point to select a conservative target, which would mean that the performance improvement would actually be 1 standard deviation worse than the dataset median. So there are 3 options for users to select the type and the ambitiousness level of their target, aggressive, nominal, and conservative. What happens following the target selection is the selection of facility improvement measures within Better, and I'll talk a little bit about how this works. So let's say we're working with the same building that I mentioned earlier, and we're working with the coefficient of electric baseload. So Better determines that by comparing this given building's electric baseload, that the current performance is poor relative to the underlying database. And the user set a target for nominal. Because the target performance is better than the current model coefficient performance for the electric baseload coefficient, the target is better than current. So Better would identify 1 or more facility improvement measures that would help improve and bring that electric baseload performance from poor to median to nominal. In another example, let's say we've got an electric baseload level that's already pretty good. It's typical performance. A user has set a conservative energy efficiency improvement target. Because the target is worse than the current performance, Better is not going to select or recommend any facility improvement measures. So the next step within the analytical sort of engine of Better is calculating potential energy and cost savings. So in this case, we've got sort of a rough diagram here of an inverse model where the current heating sensitive consumption is worse than the target. So target is the darker red triangle. Current performance is worse. So some facility improvement measures are suggested to reduce that heating sensitivity. And a new change point model, a new inverse model is created with this new model coefficient, this more gradual slope for heating sensitive consumption. Better will rerun the model and get an estimated energy consumption with these new facility improvement measures. They'll take the current energy consumption, subtract out the estimated energy consumption with the new facility improvement measures, and get the estimated energy savings, and then calculate associated cost. You can see here we've got a total of 14 energy efficiency recommendations within Better, and you can see kind of at a high level how they correlate to the performance level of those 5 coefficients that I mentioned. So I'm now going to turn it over to my colleague Han, who's going to give a live demonstration of Better and show us very specifically how to upload data into Better. So Han, I'm going to turn the presenter's ship over to you.
Thank you, Karen. So I'm sharing my screen. So Karen, can you see it?
Yes, yep, looks great.
Okay, great. Yeah, so I'm going to run a quick live demonstration of how to use the Better web application, as well as what the results look like. So we're now on the main page of Better. So on the main page, we have some brief introduction about Better and the values to the users. And let's go to the how it works page. So in this page, I have some more technical details about the Better analytical engine. For example, how we use energy and weather patterns, how we feed the linear regression model to find the weather sensitivity of the building energy consumption, and what are the physical meanings of those change point models, and how we run benchmarking. Carolyn covered most of them in the presentation, and also how we recommend energy efficiency measures, how we estimate energy and cost savings, and the step-by-step guidance about how to use Better. You can also click on those links. So this link will open up slides about the more details about how to use Better. Yeah. And we also have a conference paper about the Better analytical engine. And let's go to see how actually we can run better. So the first step is to upload, the building and utility bill data. So you may notice that we have two options here. The first one is to use a better data entry template. And so to do that, we first need to download this data entry template. I'll open it. So on this template, there are like 4 tabs. On the instructions tab, we have some, description about what are the data fields that we need to provide, and some requirements for those data fields. And on the property information tab, first we need to select a unit system. So we can select from SI unit and IP unit. And we can also select this the currency type. So by default is US dollar, but you can select other currency type. And then in this area, we will input the building metadata. So you can see we have to input building ID, building name, and location. So better we will use this location, the user input location, to automatically find the closest weather station from the NOAA weather station list and download the weather data. And we also need to input gross floor area. So we use this area to normalize the building energy consumption. And we also need to input the primary building space type. So there's a drop-down list there. We can select from over 15 space types. So we will use this information to find, the benchmark statistics for this kind of building. And then let's go to the utility data tab. On this tab, you can see we also need to input the building ID. So better use this building ID to map the utility bills with the building metadata that we just input in the property information tab. And for each utility bill, we need to input the start and end date. We also need to input energy type. So there's a drop-down list, and we can choose different energy type. And we need to input the corresponding energy unit for energy type. And better will automatically, convert to units and aggregate energy consumption. And of course, we need to input the energy consumption value. And in addition to those mandatory fields, there are 2 optional input columns here. So in this energy cost column, if the user inputs, any value, then better will use this value to calculate the unit energy cost and use that to estimate the savings. If the user left this to be blank, better will use the default, unit cost information to calculate the savings. And we also have this outdoor air, average outdoor air temperature column where the user can input their own weather data. So, for example, if a user have weather station on site, they think their weather temperature is more accurate, they can provide that. And better will use this to find the change point model. And we also have a glossary of terms tab, introduce what kind of space types we support, and more explanation of those data fields. So after we input, the building metadata and utility bills, we can close it and go back to better dashboard to upload it. And alternatively, we can use Energy Star Portfolio Manager data templates to upload the data. So we have a step-by-step guidance about how to log into Energy Star Portfolio Manager and how to custom download your metadata and the meter entries. So you can follow this step-by-step guidance. So here I will demonstrate the use of the better data entry templates. Select that and upload the data entry template. So after we upload the data entry template, there's a metadata table of what are the buildings in our template. And then we need to select the building type. So here I use some simulation data in the template that are office buildings. And after we select building type, you can see that we have those little checkboxes on the left where we can choose which buildings we want to analyze. So here I will just run all of those buildings in the template. So going to the next page, we will have more settings to run better. The first setting is a savings target. I think Carolyn just mentioned. We have conservative, nominal, and aggressive. And we can also select the benchmark statistics source. There are two sources. The first one is using the default statistics that we have in our database. And but if you're a portfolio owner that have many buildings in your portfolio, you can also choose this generate option, which will generate which will feed the chain point model for each one of your buildings and generate that statistics to use it for benchmarking purpose. So here I'll just show the default option. And we also have this minimum model R-square value thresholds. So the R-square value is the coefficient of determination. Basically, the higher the value, the better that the outdoor air temperature can explain, the weather sensitivity of the building energy consumption. So let's keep it default, run it. So depending on which option you choose, the runtime may vary. If you choose a generate option, it may take longer time because we have to feed the model for each building and calculate the statistics. Okay, so the run is finished. Let's click on the portfolio output report link to see how the report looks like. Okay, so this is the portfolio level summary report. And on the top, we have an overview section, which includes the number of buildings in this portfolio, the total floor area, and some high level cost and energy savings, and the savings breakdown by electricity and fossil fuel. And recently, we just added a feature to calculate the greenhouse gas emission reduction. And if you want to know more details about those energy costs and GHG emissions, you can click on this link. So we have more detailed tables about the annual combined and breakdown metrics. So going down here, in this section, we have the top energy efficiency recommendations, which lists the top 5 energy efficiency measures. So, for example, we have this reduced equipment schedules that's recommended for 28 out of the 32 buildings in our template. And so we can click on the E measure, and we'll show which building have this recommendation, and also show some description about this measure, and some references about this measure from the DOE and national labs. And we also have this benchmarking session where we show this grouped bar charts to compare energy consumption and savings potential for each building in this portfolio. So you can see the blue and pink bars shows the annual electricity energy use intensity and fossil fuel energy use intensity respectively. And we can also see the savings potential estimated by better. So this way we can quickly filter which building has the highest consumption and which building has the highest savings potential. So those results may look a little bit weird because I'm using simulation data. And then finally we have this buildings detail section where we have this large table to compare the buildings in our portfolio, and we can quickly sort those information by clicking on the header. For example, we want to know which building has the highest electricity consumption, we can sort it. And we also show the annual EUI for electricity and fossil fuel, the annual energy cost, savings, and also the saving percentage. You can sort them. And on the left, we have this building ID column. And for each building, we have this link. So for example, if I open, click on a link, it will open up a single building report. So in this report, has similar information for the single building. On the top, we have the summary. So for this building, the location is Albuquerque, and better finds the closest rail station is Albuquerque International Airport. And we also have the energy and cost savings details. Overview and details tables. And in the savings breakdown section, we show the savings targets that we selected, which is nominal, and the energy efficiency recommendations for this building. And if we click on the details, we can find some actionable information about those EE measures. We can show some more details, including the resources for each one of those measures. And let's go back to the savings breakdown section. And on the left corner here, we also have the cost breakdown for this building. You can see what's your building look like currently. So you can see most of the costs are from the base load, which is not weather sensitive. And we can also see the typical buildings. So that's a typical building with the same location and same area. That's how typical building cost breakdown look like. And we also have this goal, which is if we implement those energy efficiency recommendations, what the cost will be look like. And we also see this cost savings breakdown. So you can see for this building, most of the savings are from heating related, and also the base load consumption. And we can also see the energy consumption trends by clicking on this link. So you can see on the left, we have the electricity consumption trends. Basically, the orange lines stand for original consumption, and the green lines stand for the predicted consumption with those energy efficiency recommendations. So in this building, we can see we have some savings from the electricity consumption, but we don't have any saving for fossil fuel consumption. I will explain this here. So in this section, we will have the weather sensitivity and benchmarking information. So you can see on the left, we have electricity change point model. So in this particular case, we have a 5-parameter change point model for electricity. And we can see this is our original, the daily energy use intensity grouped by the outdoor temperature, and Y value is energy use intensity. And we can also see how the model look like. So on the right-hand side, we have the benchmarking for each of those 5 model coefficients. In this particular building, we can see that it has a very poor heating change point. It's over 15 degrees Celsius, which is only better than 7% of the other buildings. But it has a pretty good cooling change point and cooling sensitivity. And going down, we also have the change point model for fossil fuel. You can see all 3 coefficients are typical. So that is the reason why we don't have any savings in terms of the fossil fuel. And we also have some description about the physical meaning of the model coefficients. Yeah, so that's a quick overview of how we can run better. And I think we are constantly testing and improving the features of better. So if you have any questions or technical issues, you can feel free to shoot us an email. And we are also posting updates on the news page here. So that's it. Thank you very much for your time and listening. Karen, I will hand it over to you.
Okay, thanks, Han. Thank you so much for the live demo. That's so great.
Sure. Yeah.
Great, thank you. Fantastic presentations from Carolyn and Han.
Debbie, sorry to interrupt. I do have a few more slides if that's okay.
Absolutely.
And I've seen about six or so questions coming in, so I want to just go through these last slides really briefly, because I know we do have questions. But I want to talk about how to utilize results from Better. You know, Han has given us a really nice overview of all the analytical outputs, and so I'm going to touch just on a conceptual level. Because in the next webinar, we're going to go much deeper into the specific energy efficiency measures and how to implement them in a building or across a portfolio. But, you know, some of the things Better helps us do are the following: set baseline performance, set energy performance improvement targets, and start to make the business case for energy efficiency improvements, and develop what we call a quick win strategy, which focuses first on no-cost, low-cost operational energy interventions. And having worked with more than 1 billion square feet of real estate around the world, I can pretty much guarantee that any building can find ways to save energy and energy costs through simple operational improvements. And Better is a great tool to screen your portfolio and to find those untapped energy savings. So as Han mentioned, we've got the portfolio output report, and that's a great report to determine what your baseline energy performance is for your portfolio. So what is the energy performance for your portfolio prior to implementing energy efficiency measures?
Sorry, Carolyn, to interrupt. You may want to swap your display.
Oh, thanks so much, Han. Okay. Great. Apologies for that. Is this hopefully better for everyone? Okay. In the portfolio output report, as Han mentioned, we've got these detailed tables. Right here, combined annual energy consumption. This is your building's baseline, your portfolio's baseline energy performance. The before picture, how much energy is your portfolio consuming prior to implementing energy efficiency measures. And we can do the same for cost. And these are all part of the portfolio summary reports. And you can identify these metrics by clicking on that more portfolio energy and cost details link. We can do the same at the building level. So again, with the building summary report, by clicking on the more energy and cost details, you can get an understanding of your combined annual energy consumption for that particular building. This is the energy using before you implement measures. This is your baseline against which you measure savings. You can also, you know, determine that for the cost as well. And if you're interested in knowing what your electricity baseline is, your fossil fuel baseline, that's also shown in these energy and cost tables. So I'll also just mention this really great feature which Han talked about, the energy consumption trends feature. You can, through the yellow line here, get an understanding of your building's current consumption levels throughout the year over a 12-month period. Typically, you'd see some changes. So during heating and cooling seasons, you may see a spike, and during swing seasons, you may see a decline. But again, that yellow line there would give you a sense of, okay, this is my trend analysis for my building's pre-implementation of energy efficiency improvement measures. So giving you a sense of the baseline. Targets. So I just mentioned quite quickly, one of the great features of Better is how quickly it allows you to identify realistic energy and cost savings targets for a single building or an entire portfolio of buildings. Basically, as we know, performance targets are intended to drive energy management activities and promote continuous improvement. We want clear, measurable targets in order to support our understanding of how are we moving toward our intended goals and results. So developing effective performance goals could probably be a training unto itself, but good performance goals that we've seen within the Building Efficiency Accelerator include a very specific scope, so a specific number of buildings that are part of a program or an initiative to improve performance, a time parameter, and an estimated potential for improvement that's realistic. Very often it's communicated in a percentage energy or cost savings. So Mexico City, Mexico is an example of a great target. They have a 1-year program to reduce energy consumption of private buildings in Mexico City by at least 10% annually. Their implementation of energy efficiency targets and retrofits in buildings. Cali, Colombia is another great example. 1-year program, reduce energy consumption of 14 public schools in Cali by at least 15% annually. So again, on the portfolio summary report, we make it really easy to set a realistic energy savings target. So in this case, this portfolio of 32 offices has a realistic energy savings potential of 14.4%. Targets can also be set at the electricity and the fossil fuel level, or even at the GHG level, but measuring against those targets may be a little more challenging if you're working with GHGs. Also at the building level. So again, in this building, a 19% energy savings is very achievable, 19% for electricity, 7% for fossil. Making a business case. In the next training, we're going to talk more about how to use better to conduct cost-benefit analysis and go a little bit deeper into business case. But what better can give you is the cost savings potential associated with energy efficiency improvements. And it also can give you the tools necessary to create a strategy. And so I'm going to step back just for a moment here. You know, what is an energy efficient building? We know that designing a new green high performance building is very newsworthy, but the savings, the energy, the GHG, the cost savings happen over time. So a lot of the energy efficiency potential in a building exists in the operations phase. We've seen some of the most high performance, advanced, green, state-of-the-art buildings turn out to be energy hogs. They're not operated to maximize the efficiency of their equipment and systems. And it really comes down to that operation that allows for the energy and cost savings to be accrued. So here again, energy and cost savings begin after the building is implemented. So everyone here that's overseeing a building or a portfolio is really sitting on a gold mine, and we hope that Better can help those building owners and operators target the right buildings to look at for energy and cost savings and the types of measures to implement to capture those savings. I want to mention some very interesting findings that emerged out of the EPA Energy Star program. And these were studies that were done on the US top performing buildings, the Energy Star buildings. These are buildings that are 40% more efficient than typical buildings in the United States. And what we found is that those buildings that were top performance actually had technology profiles, technology mixes that were similar to average and below average buildings. So what that told us is it's not the technology alone that's going to drive performance improvement. A lot of it has to do with how carefully you operate and maintain that equipment. So technology may not be the first place to look for savings. Buildings with less efficient mechanical systems and building materials can still achieve savings and high performance. Even buildings with the best equipment can be operated inefficiently. And also building, portfolio interventions when you want to work across an entire city may not be the same as how you would work with a single building, and Better can help in cases where we're working with large portfolios. I'm going to skip through these challenges because we've talked through so much of this, but what we know is that there tends to be a focus on technology sales, and little less emphasis on whole buildings and a little less emphasis on portfolio-wide actions to improve performance at scale. And a lot of that has to do with difficulties obtaining financing, lack of information on financial returns, and generally reluctance to replace new equipment. Also, there's a scale in terms of cost. Audits, recommissioning, capital projects, all very costly. We know that the Better analysis is free, and O&M improvements can be implemented, again, at no cost or low cost. So when we look at making the business case, we want to look at, okay, what are our cost savings potential? $1 million across this 32 building office portfolio. That's pretty substantial. And what we would recommend is taking a look at this energy and consumption savings summary that Han mentioned earlier. Here we've got, building by building EUI for fossil and electric, plus in the green, the savings potential. So hone in on that savings potential and think about looking across this portfolio and saying, okay, these are the best buildings, office 17 and 18. This is where I want to look for big savings opportunities. I might want to invest in an audit here, or I might want to do some training with my facilities management team or assessments, because we know there are going to be big savings here. These kind of mid-range performers in blue, these are candidates, I would say, for tune-ups. Maybe just some tuning of the operations and maintenance of your existing equipment. Savings exist, but it's not going to be at the scale as those office 17 and 18. And then here, offices 1 through 15, these are pretty good performers. So I would be looking at these buildings for best practices that could be shared across the portfolio. So there's a lot of information just in this chart alone that can tell us how to approach energy efficiency. We also provide the top efficiency recommendations. So here we know this is the top 5 for this particular portfolio. What's pretty cool is that I think all of these can be done at no cost. Certainly we can go into low cost, and we can also go into investment grade options. But what we know about working with, 1 billion square feet of buildings around the world is that just these 5 measures alone can turn into about 20 no cost or low cost efficiency improvement measures. And we're going to talk about each one of these measures in our next training. So if you get a recommendation from Better to reduce your lighting load, how can you correct overlit conditions? What do you do about installing occupancy sensors? How do you work with dimming control? What about energy efficiency lamps? So we're going to go into a lot more depth so you can take these analytical outputs from Better and design a strategy that's going to give you quick, cost-effective energy efficiency improvement in a building or across a portfolio. So as I mentioned, these are the upcoming topics for that next webinar. Implementing a quick wins building energy performance strategy and communicating success. We'll talk about those operational performance improvement measures, how to use a checklist we've designed just for BEA to implement those measures quickly and cost effectively, and then how to procure energy services for deeper energy savings. There are going to be savings you can't capture with an in-house facilities management team. How do you work with an ESCO to make sure that you are getting valuable financing and that you're procuring effectively? And then how do we measure and communicate our success with internal and external audiences? So that'll be the next training. We'll also have case studies, buildings and large portfolios, cities that achieve 20 to 30% annual energy savings using these tools and approaches. And so that's all for today. And thank you so much. It's been such a pleasure talking to all of you. And Debbie, sorry I went a little long. I'm going to turn the presentation back over to you.
Perfect, and no problem. I think excellent information, and thank you, Carolyn and Han, for all of your expertise and information here. Actually, Carolyn, maybe if you want to leave that slide up so folks can have your contact information if they want it. And we wanted to have an opportunity. I know that we're just 5 minutes from time, but we also did get in a lot of questions. Carolyn, I'll give you a minute to take a look at the ones that came in about the Better tool in particular, and I will go ahead and answer. There was one question about the BEA platform.
Great.
So asking who can access the services of the BEA and our technical assistance. To join the BEA, we have both organizational partners and city partners. For organizational partners, you can reach out to me and I will put my email into the chat for everyone. And we're happy to work with you about joining. For cities, we have sort of a commitment form about making a commitment to take actions on a policy and a program area and to track your progress overall. We have sort of a process that we help cities walk through from commitment through to assessing an action, developing it, implementing it, and improving over a number of years. And we also aim to connect any city or to have you join with a local partner organization who can really provide that day-to-day, more of that day-to-day support. So you can feel free for any of those to reach out to me. Again, I'll put my information into the chat box. And with that, I will hand it over to Carolyn. I know that there were a bunch of questions, in particular, one from Mexico City, that I think would be good to respond to, and then a lot of questions on some of the sort of technical details and capabilities of the tool.
Okay, thanks, Debbie. And we'll go through these as fast as we can. So on the question from Mexico City, which is related to the Mexico City team having a building challenge and, makes sense. Let's not compare Mexico City buildings against US buildings. That may create some issues. And yet we only have 10 buildings for the first phase of the challenge with 3 different building types. So do we have enough buildings to make our own benchmarks? Will the tool work in our case? What is the minimum number of buildings? So really the minimum number of buildings to create internal benchmark statistics based on our assessment is ideally we'd have 30 buildings, or we think it's about 30 to 50 buildings in a portfolio. We like to get 30 data points for each of the model coefficients, which is a lot, to really create a solid set of benchmark statistics for a portfolio. So based on what's been shared, 10 buildings, 3 types, that's quite a small portfolio, but we really are still studying building performance. And if we could maybe talk to the person from Mexico City on a separate email chain, we'd love to do that, because we're thinking about features within Better that could cluster buildings within a similar type, size, and climate zone. And if benchmark statistics could be gleaned for those clusters to allow for benchmarks that are sufficiently accurate. So even if a building is in Mexico, or there's 5 buildings in Mexico, we may be able to pull data from our database for buildings that have a similar climate zone type and other features. So let's maybe talk offline. That's a really great question. We do think there's a lot of potential for application of Better in Mexico and emerging markets, but we need to work with those pilot markets to tailor Better to be effective there.
Thanks.
I also, oh, go ahead. No problem. My pleasure. There was also a question about can Better work with smart meter data? Han, is our answer there? Not yet. Right now, we're just working with monthly data. That doesn't mean, yeah, if you've got smart meter data, however, you could aggregate it up to a monthly level, and then Better could analyze it.
That's correct.
Okay, thanks, Han.
Add that capability to aggregate the smart meter data to monthly level.
Yes.
Yeah.
Yeah, that's a great point, Han. Han, I'm also going to turn these next 2 questions over to you. Do we consider relative humidity with Better, and do users need to provide anything more than outdoor air temperature when providing their own weather data?
That's a good question. So we don't use relative humidity in our, in the piecewise linear regression model. So the user don't need to provide anything else except for the outdoor air temperature. But it is possible that energy consumption is correlated to other variables such as other parameters in the weather data. but for now we're using the temperature.
Great, thank you. How to work with mixed-use space. So not all buildings are 100% office or 100% hotel, and does Better offer a capability to benchmark those buildings that are, let's say, 50-50 split. Currently, Better does not, but we are looking into that. And the way that we recommend handling that in the meantime is to break out the building, or break down the building into the unique space types, and provide data just for one space type at a time. So you'd provide us with the square footage for your office and the energy consumption for your office only. And then we'd benchmark that against similar office buildings within Better. That'll give you the most accurate results. And if you've got another space type in the building, let's say hotel, to benchmark only the square footage and energy consumption for the hotel. And basically to benchmark the 2 spaces or 3 spaces within the single structure independently. In terms of do we offer potential savings through building envelope retrofit? Better doesn't provide cost savings potential at the specific equipment upgrade level. We provide you with an overview of the types of energy efficiency opportunities that exist, and then generally the aggregate cost savings associated with all of those measures combined. So to get to that level of granularity, what would a retrofit for the building envelope cost and what my savings might be, we recommend using DOE's asset score tool. It's a fantastic, easy to use tool that can give very specific information about the cost and payback of equipment retrofit. So Better and asset score can be used hand in hand. The other question was about how to prioritize energy efficiency measures in a set of buildings. So hopefully my last couple of slides helped with that, where you're going to get with Better a list of energy efficiency recommendations on a building level and at a portfolio level. In terms of prioritizing the measures, we would recommend implementing those that are the most widespread across your portfolio if you're looking at a whole portfolio. If you're just in a single building, in terms of setting the priorities, we would recommend going after those that are the least cost to implement, those you can do right away, using the existing resources that are listed on the Better website. Also, the next training I think is going to be so valuable because we'll provide stepwise guidance how to implement all 14 of these measures. And then, not only that, but how to implement, some additional, I think we've got 10 additional measures that are related at no cost that you can really start to see those energy and cost savings accrue. So we recommend starting with the simple no cost, low cost measures first, doing those that are most applicable across the portfolio first. So you're starting to develop capacities when your in-house facilities team on how to implement these measures, and then later going after procuring energy services. So I think I've covered most of the questions, I hope. I think we've covered all of them. And we thank everyone so much for attending, and we'd love to hear from all of you with questions, comments, thoughts on Better, how we can improve this and make it more effective for the BEA partners.
Thank you so much, Carolyn. There are a couple of additional questions coming in, but with an eye to the time, I think I know a lot of people have to drop off for other meetings, so we are going to wrap this up with a huge thank you to Carolyn and Han for, again, these excellent presentations and excellent information. We will follow up with you and we can follow up with answers to these additional questions. And please feel free to contact Carolyn, Han, or me with any other additional questions you have. We also really encourage you to look out for the webinar invitations for the following webinars in this series on the Better tool. And we hope that we'll be able to work together to put this into practice in a lot more places. So thank you all so much for joining.
Thank you.
Thanks, everyone. Have a great day. Bye-bye.
Bye.